This conference will now be recorded.
So what's my idea is that if I start Octopus right now, it's definitely gonna take like about an hour and a half, which we do not have so much of time right now. So let's start with Dockers and understand what Docker is, and let's finish up that particular area, and then come down to Jenkins and Octopus, and then let's do the Jenkins and Octopus. Let's say over a weekend where we can spend more time on it and understand what's going around and all that stuff. So is this okay, guys? Does anyone have any objections with this plan? Anyone has any issues with this particular plan of action? Okay, if there are no issues, then okay. So I want to hear from you all. So firstly, does anyone know what Docker is, or does anyone know, or does anyone have an idea of what containerization really is? Any idea, like any vague idea is okay with me. I just want some inputs from you all. Anything. Like what do you know or what do you think about containerization?
Yeah,
And we can
as
convert.
far I know, yeah,
Hmm?
go ahead.
Yeah, we can convert everything to image. It will
Hmm.
occupy less memory, and whenever
Okay.
we require, we can use that image. When
Okay.
compared to other, it will occupy less space. So that's the
Hmm.
advantage of Docker.
Okay. Okay, fair enough. Good idea. Yes, Chandra, you were talking about.
As far I know that container is nothing but a cluster inside the cluster.
Hmm. Okay. Any more thoughts on this, guys? Any more thoughts on this one? Yes, we also got someone telling that this is an image and you can use it and it's a lightweighted and all that stuff. Yes, definitely yes. And there's a lot of fuss that is going around in the market. There's a lot of fuss that is going around in the entire IT world today, talking about what Dockers are and what Kubernetes are and all that stuff. So let's look at it at a very high level. Let's understand what really is happening out there and what really that we are going to learn and all that stuff. Now, very beginning of everything is like back in 1980s and all that stuff. When you're talking about that kind of a period, and I hope I'm recording the session. I think yes, I am. So let this load. You had physical servers to begin with, right? You had what? A physical server. So people used to buy out physical servers. They used to install different tools on top of that physical server, and then you were deploying applications on that physical server, right? So you were taking physical servers, and let's say you have three different applications you have, and these applications have some dependencies, and you are now starting to, let's say, deploy things, let's say, on a physical server out here. So what you did here is that you said application 1 has a dependency called dependency A. Application 2 also has the same dependency A. Application 3 has a different dependency called dependency B. Three applications running on the same physical server. This was able to get the job done, but the thing is that, let's say, the application 2 now needs a different set of dependencies, and you decide now to change this out. You decide now to basically change the set of dependency out here. It will also go ahead and impact the application 1. It will also do what? It will also go ahead and, let's say, destroy whatever is your running application, because this application is also running on the same dependency. One issue. Secondly, we are talking about a physical server. Now, all these days we were just seeing how to move away from a physical server, let's say, into cloud, and we were talking about the cloud technologies and all that stuff, isn't it? Because we know that physical servers are not the definitely way to go today. A lot of people are migrating towards cloud. A lot of people are already on the cloud, and all these applications have also moved to the cloud. So the next set of wave came in the form of a cloud. They said, okay, fine, physical infrastructure is too costly, and there is no flexibility in changing your dependency and all that stuff. And they said, okay, fine, now let's do the same thing, but let's take a physical server, but which is not hosted by me, which is hosted by, let's say, a cloud like Azure or AWS or Google, whoever it is. So they will buy these physical servers, install tools like VMware, hypervisor, all that stuff, all the technologies, and then let these physical servers host something known as a virtual machine. This was called as virtualization. This is now called as what? Virtualization out here. Each and every virtual machine can host one application with its own dependencies and all that stuff. So you had application and all the dependencies, and you can host multiple virtual machines on the same server. You can do that, which we have seen. And each and every virtual machine can host its own application and do all that stuff out there. Whatever it was doing, it can go ahead and do all that stuff, which is a good idea, which was running really well. Let's say over a 20-year period and all, this was the concept that was used. And later we had, okay fine, why the user wants a virtual machine in the first place? Let's use something known as a PaaS service, where Azure Web Apps came into picture and all that stuff. But underlying, you will have a virtual machine, and that virtual machine needs a physical server out here. It needs a physical server out here, and that particular physical server basically is installed with tools like VMware, hypervisor, virtualization technologies, everything that is associated with, let's say, something like virtualization. You used to install this tool so that you can host virtual machines on top of it, and on top of virtual machines you are hosting your applications. Now this is where we are, and slowly the market is now tending towards something known as containerization or modernization of all your applications, where you say that, you know what, okay fine, we still have a physical server. That is something that doesn't go anywhere. You still have a physical server, you still have a virtual machine. In this model, for one application, I'm spinning up one virtual machine. If I have 100 applications, I'll spin up about 100 virtual machines out there with its own operating system and all that stuff. But with, let's say, containerization, the idea is, let's take the application. Okay, what all the application needs. For example, let's say you have an application like .NET Core, and we said that .NET Core can run both on Linux or Windows operating systems, meaning you need something known as an operating system that can understand the code. The code has a dependency. So I am talking about three different things out here called operating system, the application itself, meaning the code itself, all in the form of DLLs, and the dependencies that are required for this code to run. So three things out here: the operating system, the dependencies, the application. The idea is, can I pack this all? Can I pack all these things out into something called as a container? Meaning, whatever is your code, whether it's Python, Java, whatever it is, let me take those dependencies and let me take the lightweighted operating system out here. Let me pack it and let me now call it as a container. So I'm packing everything, I'm packaging everything, and now it's known as a container. So container terminology kind of came from the shipping industry. So you might have seen a lot of ships, right, having big containers within it. Inside that containers, you can place anything. You can place a car, you can place a bus, whatever it is, depending upon the size of the container, you can place it, and they can be transported. Meaning, in the same way, can you transport your code irrespective of the underlying virtual machine? I'm sorry. Did anyone have any questions here? Okay, I'll just treat that as a cross echo. Fine. Irrespective of your underlying virtual machine, like my virtual machine is running on, let's say, a Windows operating system, can I now run an application that needs a Linux? Yes, you can. Meaning, this is now facilitated something called as a portability. And on one virtual machine, now I don't need so many virtual machines out here. For one application, I don't need so many virtual machines out here. On one virtual machine, I can host multiple containers. All these containers can be hosted on one virtual machine, and each and every container can host one sort of an application. Like one container can have a .NET, one container can have, let's say, a Linux, one container can have something like let's say Nginx or whatever it is, SQL servers, MongoDB, whatever it is. You can convert everything into a container and then place it on top of the virtual machine. Virtual machine is, yes, intrinsic. It's an intrinsic component. You can place it on top of a virtual machine and all that stuff. Now, For this virtual machine to understand what this container is, right? Because this container is again a tool set. It has its own, operating system. It has its own world, right? For this virtual machine to understand what this container is telling, because this container at the end of the day needs a physical hardware to run on, right? Which is a virtual machine, and virtual machine has an underlying server installed with Hyper-V and all that stuff. And for this virtual machine to understand this, you need a mediator between the container and the virtual machine itself. This mediator is called as a container tool set. We'll have a set of tools which can help you understand, or which can help you basically establish a communication between the container and your virtual machine. Meaning, without this you cannot basically establish the connection, and you cannot basically use the concept of containerization out here. Meaning, when we installed .NET, right, on a Jenkins machine, and we were doing a .NET build, it was throwing an error telling that, what, I don't understand what is .NET exe. I don't understand what .NET exe is, because I have not installed something known as a .NET SDK on top of it. So you will definitely need something known as a .NET SDK, isn't it? In order for .NET to interact with your operating system. In the same way, in order for your containers to interact with your operating system, you need a tool set. There are actually a lot of tool sets, but the very popular of everything is known as Docker. Is known as what? Docker. So Docker is a tool set for your virtual machines to understand the language of containers. So if I say Docker, the logo of Docker will be looking like a dolphin hosting, let's say, something like containers out here. So Docker is a container hosting platform. Container is nothing but operating system dependencies, application, everything bounded together. And Docker is something which will help make a bridge between the container and the underlying virtual machine the container is running on. This is what Docker all intends to do. Like, if you have a .NET code and .NET code wants to interact with your virtual machine, you need a .NET SDK, right? A software development kit. Docker is that particular software development kit, or Docker is that particular tool set to help you establish something known as a communication between the host and the container. Host in your case is a virtual machine on top of which you have a container out there. Guys, is this okay? Did you all understand what this is? Any questions still here that I can take? Anything till here?
This Docker and container, do we need to configure on any operating system or how it is?
Yes, you will need an underlying OS, you will need an underlying machine for you to configure it. When I'm talking about a machine, that machine also contains an operating system, right? So you will need an underlying machine in order to configure it. So we'll talk about how the configuration also works and all. And back in, let's say, Docker is a concept which was started, let's say, about 5 years, six years ago, I believe. Back in those days when we are looking at Docker, the only thing that was in our mind was a Linux operating system, because Docker was developed on an open source. Like, whichever development that you see today, guys, it will happen on a Linux or an open source, like a Raspberry Pi, Linux, Ubuntu, whatever it is. All are flavors of Linux operating system. So Docker came as a byproduct, or Docker came earlier as a byproduct of Linux only. Docker did not have a concept of Windows. But today Docker has a concept. Like in 2017 they have established, or they have introduced something known as Docker on Windows. It's been like about 3 years basically Docker on Windows came up. But what we will do is we'll just try to understand how you basically install a Docker. Like, if I start up a concept called Docker on Windows, right, that's again a big rabbit hole. Like, I'll need to explain what's a compiler and all that stuff. Easiest way is, how can you install Docker on top of a Linux operating system? I do not have a Linux operating system with me. I do not have something like a Linux. How can I do it? I can spin up a virtual machine on a Linux operating system. today what we did is like till now what we did is like we spend up many operating systems using Windows, right? Windows 2019 servers and etc. Let's change that today and let's start with Linux. So I'll say okay, fine. This is a Linux resource group, and I'll say this is ECS2, and I'll say review and create. And I just created a resource group out here, and I'll go into the resource group and I'll say create this out, and I'll say instead of Windows I'll say Ubuntu server 20.04 LTS long term support. So I'm creating something known as an Ubuntu operating system out here. So I'll say okay, fine, this is Linux VM. I'll say this is EastUS2, and here I am not going to take any availability options. I am just going to take the image of what Ubuntu operating system out here, and I'm okay with a B1S, like a one virtual core CPU and 1 GB memory. This is a size that I'm pretty much okay with, and even the cost is very less. It's about 500 rupees per a month, meaning if you're using it for one day, then imagine what is the cost. If you're using it just for 1 hour, then imagine what is the cost. Because this operating system that you see, right, it's an open source. It's nothing but what, an open source out here. I'll say this is password, and I'll say okay, fine, this is same password as test user and Microsoft -001. I'll say Microsoft -001, Microsoft -001, and I'll open up a port called port 80 and SSH. SSH is a port equivalent to RDP in our Windows machine. Okay, if you want to connect to this particular Linux, you need to do an SSH into it. So I'll say disks premium is very good with me. I'll say okay, fine, whatever it is, give me that one. I'll disable the boot diagnostics, and I'll say review and create. So I am just creating a virtual machine that is running on an OS called a Linux or an Ubuntu operating system underlying. So Ubuntu, like people call it in a different way, but we just need an image of this particular operating system, and it'll just ask me for my number out here, like just taking the contact and everything basically that the account was created on. So I'll say okay, fine, and this is the amount of cost that you'll incur per hour. Same thing when you compare it to a Windows operating system, it was taking you somewhere around what, the same version, somewhere around 3 rupees. So 3 times the cost. 3 times the cost, it's cut down completely because you're not going for a licensing and all, right? It's open source. And I'll say create. So I am just creating something known as a Linux operating system. So my idea right now is that let's create something known as a Linux operating system out here. And on top of the Linux operating system, let's install Docker. Let's install Docker on top of Linux operating system, because we want to do what, containerization on top of it. So what I'll do is I'll say in order to basically see how to install it, you will have Docker documentation, like very wonderful documentations they have. Like if you want to look at, let's say, Azure documentations, right, you'll do docs.azure.com. If you want to look at Docker documentation, just do docs.docker.com, docs.docker.com out here. And I just want to see download and install, and I want to basically install this on top of, let's say, what, Linux. It says Docker for Linux, and it says okay, fine, this is how you install it, and these are some commands and all that stuff. So again, there are a few commands. Everything in Linux kind of operates in a command. So you have a few commands out here to basically go ahead and install it, and you can look at these commands basically. For example, I want to install it on top of Ubuntu. It says Ubuntu something something something, and these are the commands. All these are, let's say, the commands basically that will help you to get all these things out. So what I did is that I condensed all these commands, and I have, let's say, I have put all these commands, let's say, in my local machine. So I've just made sure to condense all these things out, and I'll also share this on how to do it. So this is how you basically install Docker on a Linux. Like you have something like package update. Like firstly you'll have to update your packages and etc. We'll see how to do that. So let's see firstly our Linux firstly let's see our machine. So the machine is ready. And guys, I have placed all these commands, right, whatever we'll be using, in the Azure Git repository in something known as my classes repo. this is a public repository, this is a public project. If you go here, and there's a repository called Docker. Inside Docker, I have put in all the commands basically that we need, whatever we would need, and etc. So I will just give you this link. You'll be able to open this up without giving ID and password, because this is a public repository that I've created. So I'll just post this link out here, and I've just posted this link out here. You all can check this out if you all have access. If someone doesn't have access, please let me know. I'll arrange this accordingly. So these are the command set what we need to use. And where I got this commands from, I just went to the documentation, took all the commands, and I'm just putting it out here. So I'm not writing anything. I am not doing anything different. I am just going ahead here, and I want to basically take all these things and install something on top of it. So I am here on my virtual machine. I just created a virtual machine. So can I basically copy this and do an RDP into it? So I'll just try to open up a Windows desktop connection. And I'll just say connect. So guys, can I do an RDP into it right now? Anyone?
No, because RDP port is different, SSH port is different.
Exactly. And you do not have a concept called RDP for Linux. You do not have a concept called as RDP at all for Linux. And it's saying, you know what, this is what it is and all that stuff. Because the thing that I've created is a Linux operating system. And for Linux, you need a client to, or you basically need a separate client out here. And I'll be using a client called Putty. Just do a Putty download install. Very simple tool. An SSH client. So this is going to be a download link. Just click here, install this out, and after installation you will be able to see this something like this. This is a Putty operating over a port called 22 SSH. I'll say open the connection. It says yes, I want to accept this out. Now it's asking me how do you want to log in. Let's expand the screen out. I'll say this is a test user. I'll say this is Microsoft -001, whatever the ID and password what I've given. And you type the password, you won't be able to see this password out here. That's a limitation, or that's, let's say, how Linux normally works out. So I just put in a password, and if your password is wrong, right, you'll just get an authentication letter telling that your password is wrong. Please give a proper password and etc. What I am going to do out here is I'm going to open my notepad file. This is the command basically. These are all the commands basically that I'll be using, and I've put the same thing in here also. Install Docker VM and all these things I've pasted in here also. So same thing that I'm going to use. Whatever is there here as I'm going to use. The first command that I'm going to use is called sudo as in super user or the root user apt get update, meaning whatever are the packages that are there right now on your machine, meaning on the virtual machine, please update them, because this is something that I'll be doing every time every time when there is a new software basically that I install on top of my machine. So I'll just copy this command. So I'm doing Control C, and there is no concept of Control V here. I'll just do a right click. I'll just do a right click on the console and you'll get this out. And I'll say enter. This is now going to update all the packages, meaning whatever are the packages there, that those were very old when you installed it. Now it's going to do a sudo get apt, meaning as a super user, go ahead and update all my packages. The first command that I did is this. So here, this command, I just picked it from here. So if I even want to pick it from my documentation, let me go to the documentation, and this is the command. So I just pasted it this way so that, you know, whatever I pasted it in this quotes, right, or this double slashes, they are comments. I'm just telling what you need to do. Now I am just putting something known as sudo apt get update, which is the actual command out here. Now once this is done, this is what the Docker documentation tells me to do even before I install Docker. This is a step, and line number 29 is where I install Docker. But even before I install Docker, I need to do all these things out. That's what the documentation really tells you, that what you need to do and all that stuff. Do you really need to be concerned about it? Not really. It's a very simple installation. Like, you know, what you need to install and all that stuff is already there in the documentations. So I am saying, okay, fine. This is the first command. I'm done with it. I'm taking the second command right now, which is sudo apt install some transport layer and everything, because Docker needs to communicate with your operating system. You need the certificate and all that stuff. So I'm just copying it. Let me clear the screen. So I'll just do a clear clear, and I'll just do a right click. Second command, just sudo apt install something 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 and enter. It says, do you want to continue? Yes, I want to continue. It says, okay, fine. I'll install the transport layer and all that stuff, and I'll make your system ready. It's done. Secondly, you have this command out here, which is curl something like this. Go to that particular website and add a key. So it's going to docs.docker.com something something something, and it's adding a key out here. This is important. So I'm just copying that out, pasting it out here, pressing enter. It says, okay, fine. I pasted it, which is good. Then finally, for Docker to really be installed on your machine, you need a repository on your local machine, meaning you need a repository on your Linux machine, for which I am basically using this version. I'm saying, okay, fine, sudo apt, and where did I get it? Everything from the Docker documentation. So I am just putting up a stable repository for the Docker, and I'm saying, go ahead with this. So all these are the prerequisites. Do you really have to understand what these are? No, not at all. Not at all, no concern at all, even if you don't understand this out. The only thing that you need to know is that you need to basically go ahead and have all these things out before you go ahead and install Docker. Now, after I installed all these things, right, there are a few packages that I need to update. So I'll again use this command called sudo apt get update, put it here, and do an update out this. Updated my packages. Finally, I will go ahead and install Docker. I will go ahead and do what? I'll install Docker on top of it. So this is now going to install something known as a Docker engine on top of my Linux virtual machine. This is the phase where I install Docker. So what I did is, this is the command that you need to understand. Sudo meaning as a super user or as a root user, go ahead and install something known as a docker-ce. CE is nothing but a community edition of Docker. You also have something known as Docker EE, which is a paid version, which is an enterprise version. But I did a Docker CE, which is a community edition, and I just use this command to install this out. And if I just go ahead and do this command right away, right, it won't get installed. It will throw errors and all that stuff. There will be compatibility issues and everything. So that's the reason we did all these commands out here. All these commands out here is something that we did, and we installed this out. Okay, guys, good till here. Any questions still here? So what I'm doing,
This Docker is freeware, right? Sorry, this
Docker
Docker is freeware or?
was freeware, meaning Docker is an open source. The community edition is free. The enterprise edition is not. Even if you go to Docker documentations out here, and if you say Docker community or enterprise edition is something which comes with a cost, or what, or you, I'll say, just say cost out here. You will have a pricing plan for something like this. If that enterprise edition is just like zero, I mean just like a personal, nothing. If you're using it for a business, it will be charged for one user per a user per a month and something like this. Enterprise edition is charged, community edition is not. So two
Okay.
versions out there.
Do we have support for this?
For community edition,
Yes.
minimal support is there. Yes.
Okay.
Like you'll have minimal support. And one thing, Sanjay, you'll have to remember is this is open source. You are now dealing with open source world. So open source, if you need a support, the only support you'll basically get, or the only support you'll basically have a lot, is from Google and forums of Docker and everything. So you'll need to basically see what your issue is, and you'll basically need to see, understand what is there and all that stuff. Okay.
Yeah.
Okay. Now I have installed Docker. What should I do with this? Now we said Dockers are for containers, right? We said containers has an OS dependencies, images, and all that stuff. But how are these created? What are these really? I mean, what is the composition of a container? Now I'm going inside a container and I am saying the actual usable unit is called as an image. Is called as a what? Image. And we also created some images, right? In a concept called VM generalization. What we did is we converted our VM into an image, meaning it's nothing but a code, a binary that when used will give you a virtual machine. In the same way, you have, for example, a web server called Nginx. Web server called what? Nginx web server. This is an Nginx server, very popular in the Linux world. Similar to IIS in Windows. Similar to what? IIS in Windows. It's called as an Nginx server. You have an image, meaning developers like me, developers like a lot of people, have converted the entire Nginx software into an image. This image has the operating system on which Nginx should run, the dependencies, the applications, and everything. They converted it into something known as an image, and they put that image into something known as a Docker hub. Docker hub. Docker hub is nothing but an image gallery. Docker hub is what? An image gallery out here, and you can search for images out here. For example, I'll search for Nginx. You have the official publisher of Nginx giving you something known as an image out here, and you can pull this image using a docker command. See, it says docker pull Nginx. This is how you can use your Nginx, or this is how you can use your image and everything. Meaning an image is the actual unit, and when I want to convert, or when I want to actually use my image, I will convert my image into a container. So container is nothing but a runnable unit of an image. So image is something which is a very primary baseline for me, which is developed by a lot of people and put it into something known as hub.docker.com, which is a repository for all these images, like GitHub or for like Azure repos. I can save all my images out here. Open private, I mean, you have private, GitHub, private Docker Hub and public Docker Hub. And Nginx is an image that is available in the public Docker Hub side of things. Now, if I go here and if I want to see what are the images that are there on this machine, I'll say sudo docker image ls, meaning please in the docker, do you have any image? Please list it out. Ls is nothing but list. It's saying, okay, fine, you do not have an image right now. You do not have anything right now. So can I pull an image? Yes, I can say sudo docker pull and then the name of the image, which is nginx. It says in nginx. As I do enter, it will now go to hub.docker.com, because that is the home basically where it will look for, and it will now pull the image of nginx, and it will basically give me the nginx it will give me the nginx image on my local machine or on the virtual machine where I'm working on. Now if I do a sudo docker image ls, it's saying, you know what, you have an image that is nginx, and nginx is actually running in your machine. Now if I want to run this image, meaning if I want to initiate something known as a container, I'll say sudo docker run. Now the next set of commands what I'm basically giving will be a bit alien for you, but please bear with me for a second. I'll say p8080 hyphen d hyphen name nginx image, and then give the name of the image out here, which is nginx, and I'll just say enter. Now what I did, I'll explain what is the command that I used. I'll explain what all this is and all that stuff. But if I now go into my virtual machine, if I open up my port 80 out here, Do you now see there is a service called Nginx running on top of it? How was it able to run? Because I initiated a container out here. And if I want to see what are the containers that are running on my machine, sudo docker container ls list, and I have an Nginx engine that has a container ID of something like this running on top of my virtual machine over a port called 80. Meaning what I did out here is the command that I used out here is something like this. I said sudo, which is a super user. I said docker run. As in when I do a docker run, it will now ask you what is the name of the container that you want to run. I'll say hyphen hyphen name. Name of the container is nothing but Nginx container. This is something that you can give as your own, whatever you wish to. Expose hyphen p is nothing but a publish command. I said 80/80. The first 80 is the host port, meaning the port of the virtual machine. Meaning this is a container, guys, right? And the container needs to interact with what the virtual machine. So I am saying the inbound port of the host is 80, meaning this host should have a port called 80 open, and this 80, right, the other 80 is the port at which the container listens to, because container also has an operating system inbuilt with that, right? So I'm trying to establish a communication between my host and the container. I'll say the container port is what, some port out here which is called container port out here, which is 80 out here, where the Nginx server listens to. And I finally said hyphen d, or you can also give it as hyphen hyphen detach, meaning run in the background, run as a process. Don't run, let's say, in an interactive way, run as a process in the backend. Just run without me seeing it. Or I can say hyphen d space the name of the image that I have, Nginx image. That's it. And I did an enter out here. This ran my container, and it's now telling that your container is now running. Guys, any questions still here? Are you all able to follow this out?
Yes,
Guys, yeah. Any questions with this? Any question with the command that I'm using out here? And I've also posted all these commands out here in, let's say, the repository. Where is that repository? I posted this command here also. I did directly a run. I did not do a pull. Sorry, there's also pull. Sorry, yeah, there's a pull, and here it's pulling a specific version. You cannot, I mean, you can basically just pull it directly without a version out here. Let me, for ease of use, let me edit this out. Let me say comment. So for ease of use, I've also taken out the version out here, and I'm just saying pull the Nginx image, and I'm running the Nginx image. Now you are able to see your container, or you're able to see your virtual machine running the Nginx or the web server called Nginx out of a container. Now this is running out of a container. Now if I want to stop this, I don't have to stop my virtual machine. I can say sudo docker stop and the ID of the container. I can say 38E, the first three letters of, let's say, the ID of the container out here. This is stopped. Now if I do a refresh, now if, let's say, I do a refresh, you won't be able to get anything out of it. You won't be able to get anything out of, meaning, did I shut down my virtual machine? No. Did I only shut a container? Yes. I only went ahead and shut down, and I just shut down an operating container. I just shut down a running container out here. That's it. I did not close my operating system. I did not close the entire machine. Meaning, let's say your machine is running so many processes and just one process is your web server. Can you shut it down? Yes. If you basically use a container concept, you are just shutting down that particular container. Now imagine you have hundreds of containers running. You don't want the Nginx container. You only want to shut it down. You can do that. Now if I want to start it again, it's simple. Sudo docker container start and the ID, which is 38E. And now if I refresh this out again, I'll be having Nginx back again. Now can I run another container on top of it? Yes, you can. So for which I'll pull an image. Firstly, I'll say sudo docker pull, and I'll pull an image called httpd, which is another server, which is a web server basically that is running out there. Now it says you do not have that image, and it's now pulling the image out here. And now if I do a sudo docker ls or sudo docker image ls, now you see you have an Nginx, you have a httpd, both running on the same virtual machine. Now I want a container out of httpd. What I'll do is, like, I'll say okay, fine, sudo docker run name httpd web server port. I'll use a different host port because 80 is already used, 80 is already exposed, and I'll use the container port as 80 because httpd listens there. So number of container ports, yes, not a problem. Run in a detached mode, and the name of the image, which is httpd. Now you can see that if I basically go here and if I basically take this out in an incognito window, 8080 probably won't load because the networking port is actually blocked. So you even need to basically allow it at an infrastructure level. So if I open this port out 8080, you'll be able to see another server that is running on top of it. So where is that? Yes, now you won't be able to see it because the port is blocked. You only have like 80 and all that stuff. So I'll just add an inbound port rule out here just for REs at 8080, and I'll just say port 8080 allow. And I'll also basically allow the outbound port so that it doesn't block our operation out here. But right now, if you look at the containers, right, if I say sudo docker container ls, I'll have two different containers running on two different ports, one running on 80, the other running on 8080. So let me now go here and let me unblock this out. So inbound port is allowed, outbound port is also something that I want to basically open this out. Say out, and if I now load this out, it works. This is the httpd server that I am running out of a container on the same virtual machine. Now imagine the possibility. You can have multiple containers running on your machines or running on your virtual machine, different containers listening upon different ports, and now you can stop what you want. You don't have to stop your entire virtual machine out here. You don't have to stop the entire infrastructure out here. You can just do a selective stop out here. Meaning if I don't want, let's say, the Nginx engine running, I only want the httpd, I can say sudo docker stop. I can only stop, let's say, the http which is running, let's say, on a container ID called 25d something like this, right? So I'll say it is 25d. It will just stop that. And now if I just just try to open this up, it'll just tell me that, you know what, it doesn't work and all this stuff. So I can do a selective start and stop and all that stuff. And if you don't want a container, I mean, right now the httpd is like in a stop state and you don't want it out, how can you remove it? Sudo docker rm remove the name of the container or the ID of the container, which is 25d. The container is removed. Now if you do a sudo docker container ls, you won't have that container at all. You won't have that container at all. So this is how you can remove things out. This is how you can run. This is how you can remove out. So this is a very faint or a bare basic introduction to what dockers are and what are the different commands that we are going to use. We are going to use them more. We are going to see and we are going to delve into it and see what are these commands, what you can do and all that stuff. Is this okay, guys? Any questions here? So we've installed a Docker engine on a Linux operating system that is hosted out of Azure. So use the few commands and install things out there. Yes, Chandra, go ahead.
Yeah, so currently we are using existing images as a containers. So can
Correct.
we use customized containers?
Definitely, yes, you can do that. I'll also show you how to do that. That is going to be the prime concept of what we are, kind of reading out. But before that, let's get used to what Docker is and let's get used to these commands. And very simple commands, guys, like, just 4 or 5 commands basically that you need to understand on how it works and all that stuff. Now the question here, or something which is very popular out here, is that you have 2 different containers, or let's say you ran a container and you said -p, meaning publish the host port on 80. You have nginx container running on 80. Can I have another container called IIS container running on the same port? Answer is no, you cannot have it, because the host port is exhausted. 80 on the host is exhausted. Can I reuse the container port? Yes, you can. That's the reason when I put in another command called docker run httpd, right? I did it on an 8080 port. I said it is httpd, port is 8080 for the host, but docker port or the container port is still 80 -d in a detached way. And I just downloaded that image called http, right? So I just basically went ahead and used something known as httpd out here. Okay. So this is a concept which is important. Host port and the container port used to basically expose your ports and make sure that your container is exposed to the internet. If you don't want to do it, don't give this command. Don't just give this command, that's it. But your server will not be exposed on the internet. It will be a private server out there. Guys, is this okay? Any questions here?
So we can use only the websites instead of other things like other applications.
No, you can also use other applications also.
Okay.
Like you can do any applications, whatever you're doing, let's say, or we, for example, we went ahead and we deployed something like .NET Core on a, web app and .NET Core, let's say, on a Windows VM, right? We can do the same thing and we can containerize the entire thing also. Whatever you do, let's say, on the outside world, you can do the same thing in the container world also. But I am just showing a web server because it's easy to follow. We will see how to do a .NET Core.
Okay. So I can make my current laptop to the image and I can use it as a container.
If you want to make your current laptop as an image, it's a bit tricky because there's a lot of things like firewall and everything basically that goes into it. But if you want to do your current laptop, yes, you can. But if you want to use a virtual machine as an image, yes, you can. But mostly, right, it needs these 3 things. A working container needs these 3 things out here: an application, a dependency, operating system. 3 things out here. So that's the reason we don't look at containers for a consumer, based view as such. We are looking containers for an application based view because that is what you are going to really use out there.
Yeah.
We will see also that and how to do that and all that stuff. That is going to be the concept that we are looking in tomorrow. is how do you make a container, or how do you make an image of your own. Let's say you have an application, you created an application, a .NET Core and all that stuff. How do you make an image out of it? Let's see that. Any more questions with this, guys? So please follow along. Please create a Linux virtual machine, very very cheap. Like even if I use it for an hour, I don't want to. I don't have to, back of my mind think about how many amount of credit it's going to burn and all that stuff. Very very, not, I mean, inexpensive, very cheap as such, but very powerful. And we'll see how to use this and all that stuff. Okay. So please use this link that I've given you. Please go through the commands and please create a Linux virtual machine, download putty and try to do an SSH into it and install Docker and do some basic commands out here and spin up an Nginx container and see how it works out. Okay. So there are no more questions, guys. Then I'm good to close for the session for the day. And we'll meet tomorrow and we'll discuss more on this.
Thank you.
No problem. And Sanjay, you asked for the resumes, right? I'll send it across. I just saw your message in the morning, so I'll just send it across.
Kiran, one second. Once you said you will upload all the previous ARM template scripts in public GitHub URL. I just want to confirm, have you already done that, or are you going to share in future?
ARM templates, I haven't done it, but if you want an
You said
ARM,
you will upload all the ARM template scripts in one public GitHub URL, and you will share that URL to. You remember?
I think so. I mean, did I give anything, guys, on ARM? Like, did I give you all ARM? I don't think I have, right?
Yeah, I think you haven't gave any
Okay,
URL to us. You said you
okay,
will
no
upload
problem.
all the ARM templates.
Sure, I'll just upload. I'll just use this, the Azure repos, and I'll just upload the ARM templates as well out there. Okay, like whatever we have
Thank
discussed
you.
till now, I'll just upload that. It'll be a reference, good reference for you all. Yeah, thanks for reminding me.
Yeah.
Okay, guys, thank you so much. I'll meet you all today, and we'll discuss more on Docker. So it's going to be really very interesting. Believe me, just go through the very basic concepts of it today, and just see why are Dockers, what does it need, and all that stuff. And we'll look at it further. Okay. Yeah. Thank you so much, and have a great day ahead.